One of the ways to solve a quadratic is by taking the square roots. This method works if you have an equation that looks like this. Ax squared plus c equals 0. There can't be a bx term. Otherwise, you can't use this method. All right, so your steps to solve are first, isolate the x squared. And what that means is get x squared, or whatever variable, usually it's going to be x, but get x squared by itself on one side of the equation. A lot of times people will forget part of this step, and I'll show you an example later on of what I mean. After you do that, take the square root of both sides. Now, we got to talk about square roots a little bit. If I talk about the square root of 4, there's actually two things that multiply. So the square root means what do you multiply by itself to get that number? 2 times 2 gives you 4. So the square root would be 2. But -2 times -2 also equals 4. So really the square root of 4 is both the positive and the negative number 2. So there's two answers anytime you take a square root. That's what this says. Remember that a positive number always has two square roots. All right, so in this example, this is the x squared that we're trying to isolate or get by itself. To do that, our first step would be to add 49 to both sides. That gives us x squared equals 49. Second step, take the square root of both sides. So I'm going to square root. Now here, the square root of x squared, a square and a square root cancel each other out. So this cancels this out, and you get just x. And then the square root of 49 is both positive and negative 7. Don't forget to put both of them. You can write it this way, or you can write it as x equals 7, x equals -7. Sometimes you'll see it written in braces, -7 and 7. Those are your solutions. Either of those ways works. Just make sure you include both the positive and the negative. All right, so let's do a couple more examples. On this first one, we're going to add 16. X squared equals 16. Take the square root of both sides. Square root, a square root and a square cancel. So x equals, and then the square root of 16 is positive and -4. There's your answer. All right, let's do number 3. Trying to get x squared by itself, so we're going to subtract 25 on both sides. X squared equals -25. Square root. Now this one's a little bit different. So a square and a square root cancel, and we have x equals. But if I go to take the square root of -25, it gives me an error. That's because there's nothing you can multiply by itself to get -25. So 5 times 5 is 25, and -5 times -5 is 25. But none of those give you -25 as an answer. And you can't mix and match different numbers. These have to be the same. So if you end up with a negative under your radical or your square root, then this is no solution. Or no real solution anyway. All right, let's move on to number 5. First step would be add 5 to both sides. Gives you x squared equals -4 plus 5 is 1. Take the square root of both sides. X equals positive and -1. Now let's talk about what these answers mean. Okay, so the other day we were talking about if you had a graph and you had a quadratic graph on there, your solutions would be wherever your graph crosses the x-axis. These solutions are those points right there. So algebraically, we're determining what these points are without having a graph to look at. Now, number 7 is that example I told you I would tell you about. Okay, a lot of times people see this and they think, oh, the x squared is by itself. It's not actually. You have to get it just x squared by itself, the part that's being squared by itself, which means we got to get rid of this -2 first. So we have to divide by -2. That gives us x squared equals 49. -98 divided by -2 is positive 49. Square root, square root, square root and a square cancel. X equals positive and -7. There's your answer. Those would be the points where it crosses your x-axis. Number 9 is a 2-step. So we have 2 things we need to get rid of. We're trying to get x squared by itself. Remember to get rid of your friends first. So first thing you would do is add 108 to both sides. 3x squared equals 108. And we still got to get the x squared by itself. So divide by 3 to get rid of the best friend. X squared equals 36. Square root, square and a square root cancel. X equals positive and -6. Make sure you're including the positive and the negative. All right, let's skip to the next section. You can come back and work on those problems, but let's look at the back. There's a couple problems at the top that you got to be careful of, like number 15. You have x squared in 2 different places. Okay, you have to get your x squareds together. So let's do this problem. First thing we need to do is get our x squareds together. So let's subtract x squared, subtract x squared. Okay, to move it to the other side. So if I have 5x squareds and I subtract an x squared, now I have 4x squareds minus 1 equals nothing or 0. All right, then I'm going to add 1. 4x squared equals 1. And divide by 4. Ran out of room. So x squared. Now, leave this as a fraction. You might be able to look ahead and say, well, I know both of those are perfect squares, so when I take the square root, those will come in handy instead of doing a decimal. All right, so now we're going to square root, square root. When you square root a fraction like this, now you can type it in your calculator or you can just break it down. This is x equals positive and negative. The square root of 1 is 1. The square root of 4 is 2. So the square root of 1/4 is positive and -1/2. All right, so you should be able to finish through 16 on those. This next section is where it gets a little more interesting. All right, so we're going to solve it the same way. So first thing I need to do is get my x squared by itself. I'm going to add 3, x squared equals 3. All right, the reason these are irrational solutions is because 3 is not a perfect square. So when I go to square root both sides, there's nothing I can multiply by itself to get 3. And if I type that in a calculator, it gives me a decimal. We don't like decimals for these. So all I have to do is see if I can simplify it. Think back to unit 1. This is just 1 times 3. I don't have any pairs, so it's already simplified. So my answer is positive and negative square root of 3. It has a square root in the answer still, which makes it irrational. All right, let's do another one. So number 19. First step would be to subtract 8 on both sides. So now we have x squared equals 48. I have the x squared by itself. To get rid of the square, I'm going to square root. 48 is not a perfect square, so I need to see if I can simplify it. I know I can do 6 and 8. This would be 3 times 2. This is 2 times 4. This is 2 times 2. And I'm looking for pairs. So I have a pair here and I have a pair here. And remember, the pair comes out front. And if you have multiple pairs out front, you're going to multiply them. All right, so x equals, don't forget your positive, negative, 2 square roots of, what did we have not paired up? 3. Oops, not 2, sorry. 2 times 2 would be 4. My bad. All right, let's do one more like this. 21. So I'm going to add 126. Two x squared equals 126. Divide by 2. X squared equals 63. Square root. X equals positive and negative. We always have to check if we can simplify. 7 times 9, 3 times 3. The 3 comes out, so positive and negative. 3 square roots of 7. Kind of had to squeeze that in there. All right. I lied. Let's do one more. We'll do 23, and then that'll be it. All right, so first step would be to add 10 to both sides. Negative x squared equals 28. This x squared is not by itself yet. You still have to divide by a negative 1. So now you have x squared equals negative 28. To get rid of the square, take the square root. Now we have a square root of a negative number, so that should jump out at you. No x needed. You can just say no solution. All right, you should be able to finish all the rest of the problems on your own.